Okay, now we will discuss about the mole concept. Now, per definition, 1 mole is actually defined as 6.02 times 10 power to the 23rd particles. Yeah. So basically, mole is how we measure the number of particles, or 1 mole is equal to this number of particles, and this number we further call them as the Avogadro's number. Now, we recognize 3 different phases. We have solid, we have liquid, or in this case, aqueous, that we will talk about more, and gas. If we have a solid, normally the parameter that we can measure in the lab is the mass of the solid. So we have the mass of the solid, and the mass is in the unit of gram. Okay? To be able to calculate the mole from gram, we use this following formulation. We symbolize mole with N, and N is equal to the mass, which is in gram, divided by what we call the AR if it's an element, or the MR if it's a molecule or a compound. MR is, as you might have known, is the total of the AR that composes a molecule. So to get mole, we can take the mass in gram and we divide it with either AR for element or MR for the molecule, and vice versa. For aqueous system, we normally have the volume, which is in liter, and we have what we call the molarity. Molarity is a measure of concentration of particle, in this case, in aqueous phase. Molarity is defined as capital M like that. It's equal to a mole divided by the volume. Don't forget that the volume has to be in liter and the concentration has to be in molar. So the unit is molar. So if we have the data of molarity and we have the data of volume, we can also calculate the mole, and vice versa for any of these parameters. And here is N of the solute. N is mole of the solute, while V is the volume of the solution. Now for gas, we normally assume an ideal gas system. And for this, we have the formula of PV is equal to nRT. And for gas, normally we have the data of pressure in atm, the volume in liter, and the temperature, which is in this case is in Kelvin. And R is an ideal gas constant, which is equal to 0.082 liter atm over mole Kelvin. Therefore, if we put the R here, we can see also that the volume has to be in liter, the pressure has to be in atm, and the temperature has to be in Kelvin. In conclusion, if you would like to measure the mole or one of these parameters, first you have to see whether you are working with a solid, an aqueous system, or gas system. Because for any of the system, you have parameters that you can use to measure the mole. Another common problem is the dilution in aqueous system. In this case, if you have a certain aqueous system or certain solution, and then here you have the first volume, which is volume 1 and molarity 1, and then you put this and mixed it into more water as a solvent, so you have now a diluted system with volume 2 and molarity 2. Now, when you performed these types of dilution, the mole will stay the same because you cannot introduce or create particles nor destroy them. Therefore, N will still be the same for both system, and therefore V1 multiplied by M1 will be equal to V2 multiplied by M2. And this is the formula of dilution. To understand this problem better, let's try to solve this exercise. What volume of 6 molar hydrochloric acid must be diluted to obtain 5 liter of 1.5 molar of HCl? And how much water should be added in liter? So of course, to tackle this problem, again, we use the formula of V1. M1 is equal to V2 M2. So very easy. You don't know the volume of the 6 molar HCl. So let's write down as V1 still times 6 equal to 5 liter times 1.5. So here you will get that the volume that you need to dilute is 1.3 liter. And because the V2 or the final volume is 5 liter, the volume of water that you need to add is 5 minus 1.3 liter, which is equal to 3.7 liter.